What's up, boys and girls? Brad the Guitarologist here. In this video, we're going to open this box and we're going to do some repairs and modifications to the amplifier inside this box. If that sounds like something you'd be interested in, stick around. This is a early to mid 60s Gibson Falcon, and it looks like the faceplate has undergone some modifications of its own. Somebody's colored in all this or painted in all this. All right, so a pretty good packing job. Looks like it made it here in one piece. This amp has got a lot of normal cosmetic wear around the edges, little things here and there. The biggest thing, you know, the faceplate has been painted in this area. I'm not sure why somebody would have done that. I don't know. That's hard to explain, that one. One of our knobs is missing the little cap on it. You can actually make one of these caps if you get the more modern Gibson knobs that have like volume and tone written in there. You can actually very carefully scour off that's in there and paint a red arrow if you want. That is possible to do that. And actually, the funny thing about these knobs too, I'll demonstrate on this one. You look at the bottom of it, you'll see the numbers are there and they're just painted in black. So that's how they made these amp knobs. They're the same as the guitar knobs. The numbers are just painted in black, and then they've got an arrow instead of the volume and tone. Okay, so the deal with this is, I think he was having some issues with it, and also he wants full service. Caps, anything that's bad resistors, bad caps, that's all got to be replaced. And also we're going to do my normal mods that we do on one of these Falcons. So let's go ahead. Actually, first let's turn this thing around. We'll see what we're dealing with back here. Oh, for anybody's counting too, the serial number on this one is 486805, and this one has the brown Tolex. So this is probably at a 63. Yes, 220303. So 1963, the third week on the original Jensen speaker. We have 1962 on this little reverb. Up here we have 1963, third week on that transformer. But yeah, it's 1963 amplifier. We do have a foot switch, and it is the original. Usually, I've talked about this before, usually you don't find these with the foot switches missing because the foot switch was hardwired. Somebody would have had to actually cut the foot switch out of the amp in order to find one without it. So probably before we do anything else, let's see what it's doing or not doing, just out of curiosity. First, let me check the fuse. Let me make sure we don't already have a blown fuse. We do not, so that's a good sign. It looks like a slow blow 1 amp fuse, so that's correct. This thing does have a kind of a pronounced musk of cigarette. It smells as if the Marlboro Man and Joe Camel have been playing footsie inside this thing. We'll pull the tubes and stuff and look at those a little bit later, but first I just want to fire it up and see what it's doing. I'll put it on the Variac here, and we'll dial it up slowly at first, just to make sure nothing blows or anything like that. Make sure we don't have any shorts. As of right now, we're 60 volts in. We're only dissipating 10 watts, 11 watts almost in total. So that's almost nothing really. But the tubes haven't really started to conduct yet. So as they start to conduct, you'll see this go up a little bit. We'll go up to about 70 volts. And that's gonna allow the tubes to warm up a little bit. And we'll just kind of sit here and monitor this for a second. We should start to get sound at the output, and we are. I don't know if you can hear it or not. That speaker, though, is in terrible condition. Ooh, the speaker's destroyed. I don't know if he mentioned this when he sent this in, but this speaker, you're not going to be able to see it, I don't think, because the lighting. But inside of here, maybe you can see, the speaker is just dented, like really badly. I'm gonna have to pull this speaker for sure. It looks like something got in here and dented that speaker cone on this side, right up in here, also here. And I can already tell you, without a recone, this speaker is gonna be dead meat. It's gonna need a recone. I can tell that just by looking at the cone. It's horribly misshapen. That's a shame. I hate to see that, but in all honesty, these speakers aren't anything to write home about anyway. These are probably the Achilles heel of these amps. They kind of limit the loudness that you can get out of one of these. A lot of people think that's a really good thing, because if you're just wanting this for a studio tool, then this speaker's fine, because slap a microphone in front of it, it's going to sound fantastic, and it's going to be at a really manageable volume, because these aren't a very efficient speaker. I don't know what these are. What are these? This is C12R. So the closer you get to Z in the alphabet, the lower the wattage of the speaker. So R is pretty low. Usually the higher watt stuff will be, you know, like your N's and L's and stuff like that. So the closer it gets to A, the higher the wattage. But being an R and having a very small, you can see this is going to be a very small voice coil and a small magnet that this speaker uses. So it's not going to be a very efficient speaker. Probably for the best to change this speaker, if I'm honest. This is one of those kind of on the fence scenarios, because it is a vintage amp, but overall the amp is not in pristine condition. It's in what I would call player condition. This would be a very good candidate for just a speaker change, especially given the fact that this speaker is really nothing to write home about, even originally. So let me plug into this thing, see if we get anything out of it. Right now we're still looking good on everything over here though. I don't see anything running away, or we're only at 0.26 amps. Now we do have some tremolo. Speed, intensity are working. Okay, so tremolo's working. Reverb. I don't know, it might be working. Oh yeah, she's got all kinds of problems. Definitely got some cap issues. We've got some reverb issues potentially. Maybe even some bad tube issues going on there. We'll just have to tear it open and see. We'll come right back to you. Okay, we got all the bolts out of this chassis. Now we can pull it out. And these are a very light chassis. They're not very heavy at all, especially the aluminum ones, which this one is. Gibson made different iterations of this amplifier, and their entire lineup changed as the 60s wore on. And I think it's the earlier ones that started out as aluminum chassis, and then they moved to steel on some of the later ones. This one has a perforated bottom plate, which I have not seen that I recall on any Gibsons that I've owned or worked on yet. Another reason I love this Klein Tools screwdriver, it's just you're right on a 1/4 inch every time, and it's just no fuss, no messing around with bits, really self-contained. If you don't have one of these, you need one. This little 11-in-1. Whoever sent me this, I'm eternally grateful. This thing has been my #1 tool. This ought to be interesting to see what we've gotten ourselves into. I'm going to guess this is all original. Just because usually these things, when they're put back together, they're never put back together right. You can always tell when one has been taken apart, because they'll put this plate on the top instead of putting this lip right here underneath like it came from the factory. They'll put this plate on top. At the factory, Gibson had this adhesive strip, and then they had an adhesive strip here too. That's why, because they put this adhesive strip on, and it was supposed to kind of keep everything from rattling, I guess, is why they did that. Yes, 100% original. Well, maybe not, perhaps. Most Falcons that you see will have one of those couplets that act as a tone shaping network. We call it the tone sucking network. Gibson would have referred to it as a tone shaping network. It's basically an RC cap and resistor network that goes in between a couple of the stages to shape the tone. And what they were trying to do is they were trying to keep the amps clean so that when you crank them up loud with a Gibson equipped with humbuckers, it wouldn't overdrive. They were actually trying to diminish overdrive at this time still. This one appears to have never had it. And this might be the first Gibson Falcon that I've run across that did not have that tone shaping network, and I believe that's factory, because everything else in this is 100% factory. This is original. That's original. This spray here is original. There's the death cap. That's original. We'll replace these for sure. But yeah, man, this is all original. There's no tone sucking network in this. Usually that would be right in this area, connected to one these pots right here. And it doesn't look like anything has been replaced here either. So here's the game plan. First thing I want to do, change the power cord, remove the death cap. We will replace all these capacitors, these here and these electrolytics here, these two and this one. I'll spot check, you know, some resistors here, like this resistor. I'll check that. Check this one. Some of the, you know, more important power resistors, we'll check those. There's also another bypass cap down in here that we have to replace. I don't think this is going to need a whole lot, but obviously we've got caps to deal with first. So let's go ahead and do that, and then I'll come back to you. Okay, so I've got the nuts off of these fasteners for this speaker. We're going to pull this thing out and see how bad it is. I'm not expecting good things. See what we got. Like I said, 22303, third week of 1963. And oh yeah, she has seen better days, dudes. Whoa, oh my god, look at that. I have never seen this kind of damage. The voice coil is actually out of its magnet channel. I've never seen something like that. Yeah, this thing is toast. That's toast, boys. Yeah, that wouldn't have made any sound at all. It might be possible to reach down in there with some implements and get that reseated, but this cone is obviously so smashed. I don't see this thing ever coming back, not without a recone. So that's a shame. But yeah, that would certainly explain why we were getting very little sound out of the speaker, because it might have made a little bit of sound, being it's still in close proximity to the magnet, but it's not going to move the way it's supposed to. Very interesting failure. Very interesting. So I was sitting here racking my brain, trying to figure out what could have possibly caused damage like this on a speaker cone. And I was going back through the emails that I had with this customer. I came across an email where he said this thing was really dirty, and he asked me if I wanted him to clean it before he sent it. I said, well, he doesn't have to, but he can if he wants. And he said he hit it with the air compressor. So I'm wondering if he came in here with an air compressor and just shot air at this and forced that cone possibly to in that, because that's, see what I mean? The voice coil is completely out of the thing, and I've never seen anything like that, and it would make sense that the air compressor might have been what caused that. But I mean, you know, this is going to need a recone for sure if he wants to keep this speaker. But I mean, at this point in the shape this speaker's in, I wouldn't even recommend reconing this thing, in all honesty, just simply because these aren't great speakers even to begin with, even in perfect condition. If they're original to an amp that really means something to you, you want to keep original, that's one thing. But otherwise, yeah, man, this would be a good candidate probably for a replacement. But that just, it occurred to me that might have been what caused this damage to this speaker. Wild. I've done most of the work to get this thing up to snuff as far as being serviced. I've changed all of the electrolytic capacitors. That includes these little guys. There's one here couple in here. There was, and there's one back here you can't see. There's also a resistor that was in the power rail. This guy right here. It was kind of blackened and the value had raised as a result, so that was out of tolerance, so I replaced it. Replaced the power cable. As you can see there, it's now grounded. Most of the service stuff is done. So this thing could actually be played as it is right now, for the most part. Well, you could see that this capacitor here is kind of hanging on, and that's because I wanted to get it out of the way to show you something. So if we look at some schematics, there are two different schematics that kind of people use when they're servicing one of these GA-19RVTs. There is this schematic here that is in the Gibson Master Service Manual, and it is labeled a GA-19RVT. Gibson had a couple of different brands. They had several different brands actually in the 60s. They had Gibson, they had Epiphone, they had Maestro. Now, Maestro was the brand that was usually used for their orchestral or band stuff. They came out also with equipment for accordion, and that was under the Maestro label. The Maestro M216RVT is more or less the same amp as the one we have in front of us. The problem with the GA-19RVT schematic is that it is not accurate. This one calls for 6EU7, a 7199 in V2, which is not present in this amp. 7199 has a triode and a pentode in the same envelope, and then a couple of 6EU7s behind that. Well, what we actually have in this amp is what's over here on this schematic, which is a 6EU7, 6EU7, 6C4, and a 6EU7 for the preamp. The problem is none of this is actually really that correct. This is actually closer on the preamp section and actually the output section and everything than this one. The problem with this one is the tubes are not correct. So there's this extra triode, this 6C4 that's on this schematic doesn't exist over here, and instead we have the 7199 that has a pentode in this reverb stage. And, you know, that's where most of your differences are going to come in, is in the reverb. So, you know, the 216 is really not relevant. And if we look, we could see that. Let's just pick a couple of examples here. So the first stage right here on the Maestro is, okay, pin 6 is the 6EU7 plate. It comes off and we have a 470K feeding this plate. On the GA-19 schematic, on that same stage, we have a 220K. What we actually see inside the amplifier, if we go to pin 6, pin 1, 2, 3, 4, 5, 6, this blue wire right here, it runs over here to a 220K resistor. So it's actually more closely following the GA-19. Furthermore, you'll see, this is why I have this pulled up so you can see this down here. So you see this coupling cap, it's kind of buried underneath all this stuff in here. That is a 0.02 coupling cap. There are a couple more downstream. There's a 0.02 over here, and there's another one down here a little further. Those coupling caps in this Maestro schematic are all different. There's a 0.001 right there. There is a 500 picofarad here. So yeah, those are different. And also the couplet that we usually see in one of these Falcons is completely missing from the factory on this one. Now this one is from 1962 or 63. Most of the stuff I'm seeing on this one is 1962. We've got transformers that are date coded. Let's see, this one's date coded 1963, the 3rd week. This one's 62, the 32nd week. This one's 1962, the 37th week. So we're looking at a very early 1963. So I don't know when all these changes happened in the RVT, but they were constantly fiddling with stuff. Gibson it's really notorious for constantly changing stuff in the amps, and they really didn't update schematics because they had several companies. They had schematics under different, you know, brands. They had an Epiphone version of this too. You know, nothing was ever that consistent. We do have a couple of little 500 picofarad, and that when I first opened this up, I was thinking, okay, I just need to yank that 500 picofarad. Well, no, I don't. This is actually part of a voltage divider network. So this 500 picofarad and this 500 picofarad are on either side of this potentiometer, which acts as a voltage divider, and this is the tone circuit. So that we're going to leave in, that we're going to leave in. I don't need to really change any of the coupling caps. As you can see here, I've had to change that in the past. This coupler, though, is already a 0.02. This has already been removed. This I usually up this to a 50 microfarad. I'm not going to do that in this. Instead, I think I'm going to leave it at a 25, and I'm going to play around with the biasing on this stage, because this is biased with a 4.7K on this 216 RVT Maestro version. On the GA-19, it's biased with a 2.7K. So, and you know, other amplifiers, they will often use like a 1500 on a stage. If we look here at the Tremolo, the Fender Tremolo, okay, this one is biased at 820. So it just depends on the voltages and stuff that are present at the plate on a tube, how you're going to get the most gain out of this on your bias. So we'll probably put a decade box in there and start experimenting with some values on that. There's some other changes I want to make too, and we'll go over those after I've made some of those changes. But for now, I mean, as you can see, it's sometimes a bit confusing to sort of suss out which schematic you're looking at or which combination of schematics you're looking at in a particular example. One of the things I thought about doing also, if we look at a deluxe reverb, for instance, an AB763 deluxe reverb schematic, the screens have 470 ohm screen resistors. Marshalls will use like a 1K usually as screen resistors on the output, but usually that's for bigger tubes like a 6L6GC. This is a 6V6, and it even has the screen resistors. Most 6V6 amps that were ever made don't include screen resistors on the output. That includes this this Tremolo, for example, your Princetons. You can see here there are no resistors going into the screens on the 6V6, and that's because they were using 5Y3s rectifiers, and they were keeping things generally pretty cool and didn't reckon that they needed those screen resistors in there to stabilize the circuit. And if we go back to the deluxe reverb, you could see that it indeed had a GZ34 rectifier in here. So we're looking at higher voltages throughout the amp in that instance. And what I was thinking I might experiment with doing, because we have a situation here where we're going to have to change the speaker anyway, and we're going to upgrade it to a more robust speaker, because they really didn't put a very robust speaker in these from the factory. We have an opportunity, if we want, we could put a couple of screen resistors in, rebias this, so we could change the biasing on the output also, and we could go with a GZ34 and up the voltages throughout this thing. That would give us more punch in the amp, more low end, a little bit tighter bass, just tighter response in general, less sag. It would be more of a rock and roll amp. If we want to do that, we could do that. So that's a possibility, and it's something I'm thinking about right now. It would require us to, like I said, come in here. We'll have to put some kind of terminal here. We'll have to change the way that some things are routed. It shouldn't be very difficult to pull off, though. At one point, I got a whole bunch of these 1.1K 2-watt resistors just for the purpose of using in screens, because 1.1K is not that far off from a standard value that's often used in that position. And these were very, very cheap. They were on a clearance at one point. And so I just bought up a whole boatload of these because I knew I would use the heck out of them. So I'm going to use a couple of these resistors. I'm going to put a Softtech 5AR4 GZ34 in this amp. And I've got a terminal strip we're going to install, and we'll move some stuff around. Okay, so this is part of the power node coming in here. This is one of the resistors coming into the screen, and then we've got a wire that comes off of that and jumps over here to the other screen to this point. It's underneath here, you can't see it, but then you've got another resistor that comes off of that. So we have to take this resistor off of here, this resistor off of here, and we'll go ahead and do that first. When you go to modify stuff like this, the problem often becomes desoldering all the old components off of a socket like this. Sometimes it's better to just clip them off. It's way easier to clip them off. I don't like doing that. I don't like leaving a bunch of leads on a terminal if I don't have to. But in this case, I might have to because they've got this so tightly wrapped that without removing every bit of solder that was on this, it's going to be next to impossible to get it off. There's just so much of that old wire. Just hanging on. Yeah, I'm just gonna cut it. Bend that over out of the way for the time being. And then this one over here too, we gotta remove. Okay, there's that wire gone. Yeah, there's something to be said for mechanical connection on a terminal, but at the same time, it makes it so difficult if you're trying to remove the component. If this terminal had one more lug on it, I wouldn't need another terminal. That kind of sucks, but we'll make it work. So now what we've got our power node, which here's the reservoir node here. Here's a dropping resistor, goes to a node here, which is now on this terminal. And we come off of this terminal and we go through 1.1K resistors to the screens before continuing on downstream with this dropping resistor here. So now we can install our 5AR4 rectifier instead of this 5Y3 rectifier, and we can beef this sucker up. One more thing I know I'm going to want to do on this output is install a Zobel network. It's interesting because the Maestro version of this amp already has a capacitor across the output. You can see here there's a capacitor that goes from one side of the output to the other, but there's no series resistance in with that, so it's not really a conjunctive Zobel network like we're used to using in some of our mods. But this one, the J19, doesn't have it at all. And indeed, if we go to the amp itself, there is no conjunctive network between these 2 points. So we could add one here and really smooth this thing up. And that's probably what we're going to end up doing with this one. We do have to rebias this at some point, because this is not going to satisfy what we have in here now. It's just, yeah, we'll have to replace this resistor for sure. But we're not sure yet with what resistor we'll have to use. So we'll have to experiment with that and take some measurements and check the bias on the output tubes. But what I want to do first, while we've got this in this state, I want to hook everything back up. So let's put you back. And then this needs to go back. Let's get a speaker out here. We'll dial it up very slowly. We'll check some voltages and see where we're at, and we'll just kind of go from there. Okay, here we go. We're about to fire this thing up on the Variac for the first time. I've got a sine wave coming into the input here. We'll check it on the scope. I've got the dummy load hooked up, set to 8 ohms. Right now we're testing the bias. We want to set the bias before we really do anything else. We want to make sure that this rectifier is going to work okay, that these screen resistors, this setup is going to work okay. It should. I see no reason why it wouldn't, but we need to dial it up anyway and see. And we're going to do this very slowly. And we'll turn on our meter here. This will measure our plate current. This will be our actual plate current measured through the plate. Okay, we're about halfway up right there. A little over halfway. We'll stop at about 75 volts. Okay, we are getting a signal through. You can see how it's kind of jumping around. That's a very dirty pot. I still need a clean pot, so I'll make a mental note of that. We'll let everything come up to temperature here, and then we'll measure some stuff, see where we are. I need to measure plate voltage. My Fluke meter is on the fritz at the moment. I had to order some new battery terminals. Need to install those. Or one of my Flukes. My other Fluke is fine. We use that. We got 220 volts to cathode. I'm going to go ahead and dial it on up. We'll go full power with this. 332 volts on the plate to cathode. 34.8 milliamps. 0.035 times, say 333, equals 11.6, and that's with a 300 ohm bias resistor. We probably need to change that because that's pushing 12 watts at idle. I'm going to try a 500 ohm bias resistor here and see how that goes. Well, I'm getting 347 volts on the plate now, and we're sitting at about 26 milliamps. 0.026 times 347. That's 9 watts of plate dissipation per tube. So 14 watts is the maximum. So we'll say 9 divided by 14. That's about 65%. That's looking actually really good right there. 65% is respectable. Getting a lot of crossover distortion though before compression. I'm going to switch back to the 300 for a second. It really needs to be somewhere between the two. It probably needs to be around 400. I can tell you this wave right here is looking a lot better. It's definitely closer to what I would expect to see. We're getting the maximum headroom without any crossover distortion with this resistor. Like I said, though, the only problem is we're dissipating. It's dissipating way too high. So we need about 400. I don't have a 400, but we'll have to make one up, probably out of two 200s. Okay, now we have two resistors here in series. We have a 300 and a 100, giving us 400, 340 volts. And it looks like we're going to push probably 30 milliamps. 0.03 times 340 equals. It's 10.2, but let's see what we look like. That's really close to 70%. Let's see what we look like on the scope. That's actually looking pretty good right there. I think that's probably gonna do it. All right, guys, it's time to select a speaker, replacement speaker for this amplifier. Here's the one that was original that is damaged. I'll put up on the screen what the wattage is on that. It's not a lot. It is probably just barely enough to handle the output of this amplifier. It's probably like maybe 12, 14 watts, something like that, is my guess without looking it up. We have a couple of options here that we can replace it with. Now, this is a Weber newer speaker. It is a 12A150 model. That is a $265 speaker if I have to go and buy it. So I don't think he's going to want to spring for that because the quote that I gave him on this entire repair wasn't more than like $450. So putting that speaker in, we're going to be way over budget. I mean, by a lot. This speaker, however, is very similar to like a Jensen P12N, which is something more along the lines of maybe 20 watts or more. And it's going to easily handle the output of this amp even after we've beefed it up. So this, you can see here, came out of a Hammond organ. AO23232-0, and there's some more numbers there. This one at the end tells us that it's a Rolla. That 285 is Rolla 303. So this is from 1963, the third week, which is the exact same date code that we saw on the power transformer of the amplifier. So I think we've found our speaker. Now, this was one of a pair of speakers that came out of a Hammond organ, and I've got another one of these too. I hate to break up a pair, but sometimes it's just the way it is. I looked around in my stash, and while I have a lot of speakers, a lot of them are lower watts, and they're probably really not much better than what he had in here. And I kind of wanted to beef it up just a little bit, so I think this is the way we want to go right here. This is going to be a hell of a speaker. We can see the cone here is in magnificent shape. It's perfect. In fact, it's got a really beefy magnet on it. Very, very similar to this 50-watt Weber that we see over here. But this is what we're going to put in there. I just think it's really cool that it has the exact same date code, 1963, third week. that we saw on the amplifier. Okay, we've got the amp hooked up to the speaker, which is in the original cabinet, and we'll see, get an idea now what it's going to sound like with this speaker. I mean, it's a rocking little lamp, but it's got a little bit of harshness that I would like to remove from it. It's just a little bit harsh on the top end. I think it's time to experiment with some mods. Now, the first mod I think I want to try to make is the biasing of the first stage. Okay, so we've got a substitution box up here, and we've got it set to 3.3K right now, and I have some choices: 3.3, 2.2, 1.5. We do not have the standard 820 on here, but we do have 1000 and 680, but it'll give us an indication of where our highest output is, so that's really what we want to try to find. It's not that different, so I think I'll probably just leave the 2.7K that in there right now. Tell you what I am going to do though, I'm going to put the 2.7K back, but I am going to change the bypass capacitor. I think I want to put something a little smaller in there, actually. I don't want quite as much bass. A little bit flubby on the bottom end. I'd like to tighten it up a little bit, so I know exactly how to do that. We're going to change that capacitor. And yes, I realize that's the one that I just put in there, but I'm going to change it. And I think I want to make it a 0.68 microfarad capacitor like they use in Marshalls. Well, getting closer. All right, guys. Well, here's the fun part of the modification, if you ask me, because this is the part where it starts to sound like an end product. So we're going to add a Zobel network across this output, and it's something I like to do on a lot of amps because it just has a tendency to put that finishing touch and add a little bit of the creaminess that we're looking for. And by creaminess, I mean a lot of amps will tend to be a little spiky on the top end, and this one is really no different. It's a little bit spiky on the top end. So we're coming off of one of the plates right here of this tube. This is one of the output tube plates. We come to a resistance box here. I've got the resistance right now set at 10K. I'm going to set it to 6.8K, which is about where I think it's probably going to end up being. Then it goes in series through a capacitor In this case, we've got it set right now to 0.0015, and then it goes back to the other plate of the other output tube. So this is across the output tube plates. This is something that I saw in Hammond organs when I first started doing modifications and stuff. I would run across this network, and the amplifiers that I was testing out had this real creaminess, and I said, what is this network on the output here? What is this? And I experimented with taking it off, and I realized very quickly that it needed to be there. Ooh, it doesn't seem to like that. It has to do with interference. Check that out. Yeah, you won't get any of that in the final product, but it's kind of interesting that it was getting that interference. I mean, this is a Gibson amp from 1963, for God's sake. Listen to this thing. Crazy. Listen to that. Man, I don't know. A lot of these settings really sound great for different reasons. That sounds pretty good right there. 10K and old 0047. Actually, it's 15K. Excuse me. Psych. That was stupid. Okay, well, I just took 340 volts. That was fucking stupid. Yeah, you can't touch any of that. I knew that. I knew that. That sounds incredible. Sounds incredible. That's weak. Okay, I think 33K and 0.01 is the way to go here. Let's install it. So there is our bell network soldered in place, and we ended up using a 0.01 capacitor with a 33K resistor. The only thing left to do now is to clean these controls. Volume control in particular is very dirty. That's much better on that control. This control right here was real crusty. That's way better on that. A couple of these are kind of hard to reach. Okay, controls are lubricated. One last mod we're going to perform on this thing. There is a 500 picofarad, which is a very small capacitor, coupling from the second stage on. In this position right here, there's actually a couple. There's one going this way, and there's another coupler that comes off of this. If I look at the other schematic, this is actually more accurate in this area of the amplifier, at least. So we have a 500 pico here, and then we have another 500 pico that takes off, or that actually comes in from the reverb. So this reintroduces the reverb signal back in. And this is where they get mixed. So this 500 picofarad is much too small, in my opinion, for this position. So what I've done, we've gone back to our substitution box, and I have messed around and found that 0047 seems to be pretty magical. So I'm going to replace that capacitor in that position with a 0047. and it goes right in here. One thing I will say for this amp, it really defies the whole NASA soldering technique thing, because these components just slip into these slots and they are able to slip right out. There's no manual physical connection between the component and the terminal. It's just the solder that's holding it there. And this thing has been like this for how many years? I mean, since 1963. So I would say doing a physical connection on every single terminal isn't always necessary as people think. It is good, especially for heavier components. Now this one is the only one that concerns me because it is a little bit of a heavier component and it is soldered on the terminals, but I think it'll hold just fine, and I don't see any reason to fear that will come out unless somebody just really drops this amp from a height or something like that. I think the obsession with that sort of thing is really overblown in a lot of technical circles, and it's not that important. I think what it boils down to is there are a lot of really autistically minded people in technology who do this craft. People get obsessed by some crazy stuff. It's always fun trying to keep up with the trim to try to get that bowed effect. Alright guys, I probably pissed off the neighbors enough here, but you get the idea. This thing is absolutely incredible. After the modifications I've done to this, it's gone from, you know, about a level 6 amplifier to 11.
Put it up to 11.
11, exactly.
The speaker that I put in here this is a hidden gem of a speaker. If you can find one of these, and there's some on Reverb, they don't go for a whole lot, like 80 bucks. You can buy one. There's one on, I think eBay right now for like 80 bucks. That's what I'm going to charge this customer, is 80 bucks for the speaker, because it's well worth it. It's worth it to me to put it in something else. This thing sounds every bit as good as like a Jensen P12N from the same era. Killer speaker, killer amp. Pick yourself up one and do these mods. You won't regret it. That'll do it for this one. If you guys enjoyed, hit subscribe and all that stuff. For now, we'll see y'all later.